OpenVPN Access Server is a secure and easy way to stand up a fully featured VPN infrastructure for your organization. You can deploy Access Server in many different ways, including on a bare metal server, in Docker, or as a cloud-based virtual server running on DigitalOcean or some other VPS provider. You can secure your end users and remote sites with a multitude of multi-factor authentication options, and you can lock down your VPN clients so that they only have access to the services and subnets that you allow. In this video, I'm going to show you exactly how you can set up your own OpenVPN access server in a matter of minutes. We got a lot to cover, so let's get started. Here at Crosstalk, we've been using OpenVPN for years to securely connect to our clients' systems, which is why I was super happy that OpenVPN reached out to sponsor this video. OpenVPN is one of the most trusted names in security, and their commercial VPN infrastructure products are super robust. We're going to set up OpenVPN Access Server, which gives you full control over the server hardware for your deployment. But if you're looking for an even easier way to get started with your OpenVPN infrastructure, you should also check out Cloud Connexa, which is OpenVPN's cloud-delivered service offering. It gives you almost all of the same features as the self-hosted access server, but OpenVPN provides it as a service for you, making it super easy to deploy. Personally though, I love having the flexibility to install onto my own hardware, which is why I'm doing this video on Access Server. But before we start the installation, let's look at a couple of basic use cases. What exactly can you do with OpenVPN Access Server? The first common scenario is to use OpenVPN Connect to give your users remote access to your company's internal resources. This is a great way to make sure that you, as an administrator, have full control over what your remote employees have access to in order to get their, day-to-day work functions completed. Another example would be remote site connectivity. So let's say you've got a chain of restaurants and you want to centralize your point of sale system at your headquarters location. Each restaurant is going to have a router with OpenVPN client capabilities that is always securely connected to the access server, allowing you to centralize administration and also potentially reduce costs. You can set up split tunneling so that each remote site uses its own internet connection for normal web browsing, but certain traffic, such as surveillance camera footage or database connections, are going to be routed through to the OpenVPN access server. Now, we've set up a ton of our customers with similar deployments, and they all have one thing in common: rock solid VPN connectivity back to home base. Okay, so now let's dig into the setup of OpenVPN Access Server. I'm going to be using a virtual server in DigitalOcean since they have a one-click install that makes it super easy. But you can also use Docker, or you can set up a virtual machine within your organization. OpenVPN has really good documentation for all of this stuff in their support center. You're also going to need a fully qualified domain name for the SSL certificate. In my case, I'm going to use vpn.crosstalknetworking.com. So replace that with your own FQDN wherever I use it. All right, so once you're logged into DigitalOcean, you want to do create up here at the top and then do create a new droplet. You can select your region, just usually pick something that's geographically closest to you. And then scrolling down here, we want to click on Marketplace because again, OpenVPN has a one-click install on DigitalOcean that makes all of this super easy. Now, when you click on Marketplace, the OpenVPN Access Server droplet is right here, but you can also search for it by just saying OpenVPN up at the top, and then it's going to pop up in this list right here. Next, you're going to need to pick the size of your droplet. So since this is just a demo, I'm just going to take the cheapest option, which is $6 per month. So basic, regular, and then $6 per month. And you can always start small and then scale your server up as you add VPN connections and need more server resources. Scrolling down, you're definitely going to want automated backups if you're running your server in production. I'm just going to say weekly backups for this one. And then I'm going to use an SSH key for my authentication. Scrolling all the way down, I'm going to give my droplet a name, and we're going to say create droplet. Once the droplet has been created, you're going to want to grab the IP address for your droplet and then create a DNS-A record for your fully qualified domain name within your DNS provider. So my DNS provider is Cloudflare. So I'm going to come in here, I'm going to copy the IP address. I'm going to add a new DNS-A record at Cloudflare for crosstalknetworking.com. We're going to call it vpn.crosstalknetworking.com, and we're going to paste in that IP address. And if you're not using Cloudflare, whatever DNS provider you use is going to have a very similar way of adding this same type of DNS-A record. Next, you're going to want to connect to your Droplet with SSH using your SSH key. I'm going to be using PuTTY in this example. And once you're connected, you want to log in as root. The first time you log in, you're brought immediately to the OpenVPN Access Server Setup Wizard. Just type yes to accept the license agreement, and then for my simple setup, I'm just going to take all of the defaults. We can always change these settings later once we're in the admin GUI. Once you get to the admin user, you're going to need to set a strong, secure password. When it prompts you to enter in your activation key, you can just leave this blank for now. OpenVPN gives everyone up to 2 VPN connections for free, which is a great way to test out Access Server for yourself. Once the wizard completes, you can log into the OpenVPN Access Server GUI, which runs on port 943 by default. So I'm just going to enter in https:// the IP address of my DigitalOcean Droplet, :943/admin. We're going to get past the SSL warning because we don't have an SSL certificate yet, and then log in with OpenVPN and the password that you set during setup. So you can accept the terms of the license agreement, and then you should be brought to the Activation Manager by default. So now if you click on Get Activation Key, this is going to bring you to OpenVPN's client portal. Now, if you don't have an account, you can sign up for a free account, but I'm going to log in since I already have some OpenVPN Access Server activation keys. Once you get to this screen, you can choose the free 2-connection license, or you can purchase as many concurrent connection licenses as you need. And if this video is helpful to you and you're going to be purchasing licenses for your organization, I'd love it if you'd use my link down in the description below. Now that link doesn't change your price at all, but it does give me a few bucks for the referral, and we absolutely appreciate any referrals that we receive. For the purposes of this demo, I really only need the 2 concurrent user license, so the free one is perfectly fine with me. So I'm going to copy one of my free activation keys, and then switching back to the OpenVPN Access Server, we're going to paste that key right there. And then we want to click Activate. Okay, so it took my key and I can see the green banner that says subscription is active and operating normally. Now that we've got the server activated, let's get it updated to the latest version. The version that comes with the DigitalOcean one-click install is version 2.11.3, but the most recent version, as of the recording of this video, is version 2.14.1. So drop back into SSH, and then you're going to want to run these commands. So first, we're going to make sure that the server software is completely up to date. So we'll say apt update. Remember, we're logged in as root, so we don't need to do sudo apt update. And apt upgrade -y. Now, if during this upgrade process you're prompted with anything, just take any of the defaults. And it also might ask you or tell you that you need to reboot. And if it does, just go ahead and reboot after the update's complete just by typing reboot, and then you just connect back in about a minute or two. Next, we're going to set our server's time zone. You can view a list of all of the available time zones by running time-date-ctl list-time zones. Now that's going to give you the full list of all available time zones. In my case, I'm going to use America/Los Angeles since I'm in US Pacific time. So we're going to say time-date-ctl set-time zone America/Los_Angeles. Now if I type date, we can see that it's Pacific Daylight Time. Okay, so now let's update OpenVPN Access Server. First, we want to make sure that there aren't any holds on the OpenVPN Access Server service by typing apt-mark /unhold OpenVPN-AS. And now we can run the actual upgrade by calling the OpenVPN upgrade script. And I will have a link down in the description where you can copy and paste all of these commands yourself. I'm going to do all the heavy lifting for you to make your life easier. Okay, we're running that command. Do you want to proceed with the installation? We're going to say yes. Now, during this upgrade script, you're going to be asked if you want to install the OpenVPN DCO. This is a newer feature that came with the version that we're upgrading to. DCO stands for Data Channel Offload, and this is a service that offloads the encryption and decryption of your VPN tunnels to the Linux kernel, which greatly improves performance. So in most cases, when you're asked about DCO, you're going to want to say yes. Next, you're going to want to log back into the OpenVPN GUI, and you're going to be prompted to accept the license agreement again since we just upgraded the server. Now, you may have to close the previous browser tab and then reopen the admin URL in a new tab to get that to happen. So we'll say agree. And now in the upper left-hand corner here, we can see that we are on version 2.14.1. All right, so the next thing we're going to do is we're going to set the server's host name so that we're not connecting directly to the IP address of the server. To do that, you want to navigate to Configuration and then Network Settings. And then right now under host name or IP alias, we see the IP address of the server. So we're going to want to change this to the fully qualified domain name. In my case, it's going to be vpn.crosstalknetworking.com. Now, if we scroll down a bit here, we can find web service forwarding settings. If you leave these on, HTTPS port 443 is going to be used instead of the admin port that we have been using, which is 943. And this basically just makes it easier for our users to connect. You can choose to do this HTTPS redirection for either the admin or the client web portal, or you can do both. Now, in terms of security, leaving the admin portal on a separate port is going to be a little bit more secure because you can lock that port down to only those who need to access it using firewall rules. But for the purposes of this demo, we're just going to redirect everything through port 443. So scroll down to the bottom, hit Save Settings, and then you want to click Update Running Server. Now what's going to happen here is your browser connection to the GUI is going to disconnect because we just changed from an IP address to a fully qualified domain name. But you remember earlier, we set up our fully qualified domain name to point to that same IP address for our OpenVPN access server. So now, if you close this browser tab and then open up a new browser tab, you should be able to browse to https://yourfqdn. And since we still haven't set up that SSL certificate, you're going to get that SSL warning, but you should be able to get through that error and log back into the admin GUI. Okay, so I'm logged back in and we can see now that I am at https://vpn.crosstalknetworking.com, but we are for now not secure. So to upload your own SSL certificate for your FQDN, you want to navigate to Configuration and then Web Server. And then if you scroll down, you can toggle User Provided Certificate to Yes. This is now going to prompt you to upload 3 files: your CA bundle or the chain file, your SSL certificate, and your private key. To get these files, you can create a certificate signing request, which generates your private key and your certificate signing request file. Basically, then you just copy and paste the text of your certificate signing request into your SSL provider. So in my case, I used Namecheap because that's who hosts a lot of my domains. But really, any SSL provider should work. Now at Namecheap, I went with the absolute cheapest option, which is $5.99 per year for their positive SSL certificate. When you buy that and then you configure it, you upload your CSR, the certificate signing request. The provider is then going to have you validate your domain. Basically say, hey, are you sure that you're the one that owns this domain? And then once you've validated, you're going to get the CA bundle file and the certificate that Open Access Server needs, along with the private key that was already generated when you did the certificate signing request. Alternatively, you can use Let's Encrypt, which is a free SSL certificate that regenerates every 90 days. OpenVPN has a step-by-step guide for using Let's Encrypt with OpenVPN Access Server, which is mostly the same process as generating the certificate signing request manually, except it's done right on the OpenVPN Access Server with a service called CertBot. Now, if you guys want a more detailed look at how to do these SSL certificates, let me know down in the comments below. But regardless, however you install your SSL certificate, once complete, you can then reload the OpenVPN Access Server FQDN in your browser, and it should now show that a valid certificate has been installed. At this point, we're ready to start configuring our VPN infrastructure. For my example, I'm going to want to have remote users connecting in from their PCs or their smartphones to be able to hit a service behind my firewall. The service in this case is just going to be a speed test server running on this Minis Forum MSA1. So first we need to add a user to OpenVPN access server. If we click on authentication and then settings, we can see that by default, we would be adding local users to the OpenVPN access server. But there are a couple of other options to consider in here, such as whether or not we want to enable TOTP multi-factor authentication, which is highly recommended, and we can also set some password lockout policies as well. Now, alternatively, if you don't want local users, you can integrate OpenVPN access server into your Radius server, or you can use LDAP authentication. Now, this is going to be useful to tie OpenVPN access server into, Microsoft Active Directory or into your Radius server. You could also click on SAML to set up authentication with SAML compatible services such as Google Workspaces. For our purposes, however, local users are going to be what we want. So I'm going to click on User Management and User Permissions. To add new users, you just enter in a new username into the box here. So I'm going to call this User1. You want to click the Allow Auto Login checkbox here, and then we're going to click on More Settings. So I'm going to give the user a strong password. This is for logging into the OpenVPN Access Client GUI so they can download their VPN configuration file. For now, we're going to leave everything else default. So just go ahead and click Save Settings, followed by Update Running Server. If you're using local users in more complex environments, you can create user groups with different permissions and then assign users to those groups. So for example, if you wanted accounting users to only be able to access a specific accounting subnet, or if you have IT administrators who need full access to everything. Now remember I toggled on the Allow Auto Login button. This is going to default their OpenVPN profile to auto login. So when they download the OpenVPN Connect bundle, they don't have to enter in their password every single time they launch OpenVPN Connect and then try to connect to the VPN. It'll just happen automatically without prompting them for a password. But if you want your users to put in a password every single time, you just disable the Allow Auto Login. Now that our user is created, we can log into the OpenVPN client GUI as that user. So I'm doing this in a different browser, and when I click sign in, the client GUI automatically detects the device and the operating system for your users, and then basically gives them a default that they can just download. So right here, this download is the full OpenVPN Connect application pre-configured with a profile for that user for my OpenVPN access server. This makes it incredibly easy to onboard your users onto the VPN server. Now, if they already have OpenVPN, such as if they connect to other VPN locations, you can just click this connection profile here, and it'll download the .ovpn configuration file, which they can then import into OpenVPN Connect. Okay, so we're going to run through the OpenVPN Connect setup wizard here, just taking all the defaults. And then when we launch OpenVPN Connect, we can see that our OpenVPN profile is already bundled into this executable. So now we just need to toggle it on. Boom, there we go. And just like that, our user is connected to the OpenVPN access server. Now we've got our user connected, let's set up our router. So this process is going to be similar for any router, whether you're using something like this GL-iNet Slate AX, or if you're using a Unify system, or any other router that can function as an OpenVPN client. We'll need to create a new user for our Slate AX router, but unlike when we create accounts for standard users, I don't ever want the IP address for our router to change. We want it to be static. To do that, we're going to go to Configuration and then VPN Settings. And here we can see that our default subnet for clients, the sort of DHCP subnet for clients, is 172.27.224.0/20. And static IP address is currently blank. So let's add the next available /20 subnet. Now, /20 is a huge subnet. You probably don't need to be working with subnets that large, but for the purposes of this demo, this will work perfectly fine. So I've added 172.27.240.0/20 for my static devices. Scrolling down, we also want to set routing to yes, use routing. And this is so that our VPN clients can have access to private subnets. And we're going to specify which subnets we want our clients to have access to. Now, for the purposes of this demo, I'm going to add both of our VPN subnets, but I'm also going to add the LAN network behind the Slate AX firewall, which is 192.168.22.0/24. Notice this setting as well should client internet traffic be routed through the VPN. It's set to yes by default. I'm just going to leave it default for the purposes of this demo. But if we turn that to no, that means that only traffic destined for the VPN server or subnets that are on the VPN server are going to be routed from the VPN clients to the server. But regular web surfing or watching Netflix or just downloading files from the internet, that's going to use the regular internet connection of that client device or that client router without actually going through the VPN tunnel. It's called a split tunnel. Looking down a little bit further, we can also see there are various DNS settings as well. Now, we're going to take the defaults here, but you can leave DNS up to the client devices. You can have Access Server handle the DNS, or you can give it custom DNS servers if, for example, you wanted to use your Active Directory DNS for your VPN clients. All right, save those settings and update the running server. Now that we have our static network configured, let's create another VPN client account for our Slate AX router. So we're going to go back to user management and user permissions. We're going to add a new user, Slate AX, and we're going to toggle the auto login box and edit that user. I'm going to give it a strong password so I can download the VPN file from the client portal. And since I want the Slate AX to have a static IP address in the VPN subnet, under IP addressing here, we're going to say use static. And then remember, we just created that static network a second ago, 172.27.240. We'll call this 22 as the IP address for my Slate AX. Now under access control, we're going to say use routing, and I'm going to put in both of our VPN subnets, as well as the private LAN subnet behind the Slate AX router, which again is 192.168.22.0/24. And we're going to allow access from all server-side private subnets and all other VPN clients. We also want to set this VPN client as a VPN gateway. This means that, again, the Slate AX is going to essentially be functioning as a router. So any other VPN clients that have been granted access to the LAN network of the Slate AX, which is 192.168.22.0/24, they're going to have their packets routed to this VPN client connection, which the Slate AX is using. And then on the Slate AX router, we're going to have to tell it to allow those packets to flow through from the VPN network to the backend LAN as well. We'll get to that in just a second. But for now, save settings and update running server. Going back to the OpenVPN Access Client portal, I'm now going to log in as the Slate AX user that I just created. And I'm going to choose the OpenVPN for Linux and then download that connection profile. Now, I don't think you actually have to use Linux here. I think any of the .ovpn files will work, but I just know for a fact that Linux will work, so I'm kind of in that habit. Flipping over to the Slate AX admin GUI, I'm going to click on VPN, and then we're going to click on OpenVPN Client. We're going to add a new VPN client profile. I'll call this vpn.crosstalknetworking.com. And I have uploaded the OpenVPN configuration file that I just downloaded from the client profile. So we'll say apply. And now if I go to the VPN dashboard, I'm going to click on options here, because remember, we need to tell the router, hey, you need to route packets from this VPN network into the LAN. Basically saying that's okay that users can get through the VPN network into our backend LAN. So to do that for this router, we say remote access LAN enable. As you can see, it says if this option is enabled, resources inside the LAN subnet can be accessed through the VPN tunnel. Now, any router that you're using should have a similar way to do this. All right, apply that setting. And now we can click enable. Light goes green, trap is clean. All right, so now let's take a step back and look at an overview of what we've created. We have a laptop that's simulating a remote user. Now, this user could be anywhere in the world. It's using a different internet connection from the Slate AX, and we're using the OpenVPN Connect application to initiate a VPN tunnel out to our DigitalOcean hosted OpenVPN access server in the cloud. Then we have another VPN client connection from our router out to that same OpenVPN access server, and we've told both the router and the access server that we want any packets destined for 192.168.22.0/24 to be sent through the VPN client connection to the Slate AX, which means we should now have access to the services that are running in the LAN of the Slate AX. First, I'm going to try to ping the inside LAN interface of the Slate AX, which should be ping 192.168.22.1, and we are receiving replies. So we know that our VPN tunnel is working and the routing is also working through the Slate AX. But let's try to bring up the speed test server running on this Minis Forum MSA1. All right, there we go. So I have browsed to 192.168.22.239 on port 3000. That's my open speed test server. And if I click start, we should do a speed test, which will probably cap out at the upload speed of my internet connection. All right, so there you have it. In less than an hour, you can stand up a robust VPN infrastructure for your organization with user permissions, full routing capabilities, and everything that you need to allow secure access to your internal services for your remote users. Now from here, there are some additional best practices that you'd want to take advantage of, such as enabling multi-factor authentication, firewall rules, basically the administrative detail work that goes along with these kinds of projects. And as easy as all of this is to set up, designing out a VPN infrastructure can be challenging, especially for larger organizations. So OpenVPN also has a full team of support techs on standby, ready to help you through your VPN deployments. And you can also contact us here at Crosstalk Solutions to do the same. We absolutely love designing secure and robust networks for our clients, including VPN connectivity, so that your users have access to everything they need and nothing they don't. If you've enjoyed this video and you're planning on implementing your own VPN infrastructure using OpenVPN's Cloud Connexa or Access Server products, remember to use my link down in the description below. It doesn't change your pricing, but it does get us a few bucks for the referral, and we appreciate every referral that we receive. If you'd like to keep this party going, I have hand-selected 2 videos on the right here for you to watch next. The top video is my recent review of the Starlink Mini satellite dish, and the bottom video is a look at the WLAN Pi Wi-Fi multi-tool.